Inverse functions. Definition. Is the inverse function f of x if and only if f of f inverse of x equals f inverse of x equals x. There's your test to see if you got an inverse function. I mentioned it last time. If you got to find an inverse, do what we did last time. Switch the x and the y, solve for y. Get your new function. And then to check, do f of f inverse. And while you're at it, do f inverse of f. Okay? That's how you check it. And that's what it means to be inverse. I'm just going to comment, number 10 is a thing about radiation. And essentially, and you can read the problem, because I'm not going to read it to you or go through the details, just here's how you translate the problem. And it's pretty clear if you read the problem. It just tells you that got a radioactive substance, 9 grams now, 5.9 grams now, and 2.6 grams nine days later. Okay? What do you do with that data? What's the first thing you do when you've got data? You put it on a graph so you can focus on what you've got. So you've got 5.9 grams now, so that's 5.9 grams at what we'll call t equals 0, because we might as well, we can put our y-axis anywhere we want, but it's very convenient just to put it here. So now is when time is 0. Okay, so time is here, and after 9 days, we're down to 2.6 grams. And radioactive decay, well, it asks you what's the half-life. So if you didn't know that radioactive decay is exponential, it's only exponential functions that have half-lives. Okay? If it has a half-life, that means anytime you want to start, you go that much later and it's down to half. Okay? Just like investments have doubling times. If they have doubling times, they're exponential. If they have half-lives, they're exponential. Okay? So, you know we have an exponential function, so you just draw a graph that looks exponential, just to give yourself something to look at. And you don't have to be completely accurate. You don't have to be that good at drawing them, but you should try to be as good as you can. Okay, so there we have it. Now how do we find the function? Well, it's exponential. And actually it's time, so we better say f of t. It's in the form ab to the t. Now what do? Knowing that this is an exponential function, you know what its form is, and if you don't know that that's a form of an exponential function, you need to know. So make sure you do, okay? Well, now you should be on familiar ground. We've done quite a bit of this. You just plug in the coordinates of this point, plug in the coordinates of this point, it gives you two equations, and you solve for A and B. So I can write that down. I can say, okay, AB to the 0 is 5.9, and AB to the 9th is 2.6. Solve for A and B. On this example, it's very easy to do that because B to the 0 is 1. This tells you right away that A is 5.9. That's one of the advantages of having your first point at t equals 0. It won't always be that way, but this time it is. Okay? Then you just take 5.9, plug it in here. So you got 5.9, b to the 9th equals 2.6. Divide both sides by 5.9. Take the 1/6 power, which you should be used to doing at this point. Okay? So that's how you would do number 10, and that's how you would interpret it. And then you can use that function to answer the questions. Once you've got the function, you should be able to write equations. And this says, how long, well, what's the half-life and how long will it take to give you less than 0.5 grams? Okay? So, well, might as well finish it real quickly. So we get A equals 5.9. B is the 1/6 power of something a little less than a half. What would I take 6 power of to get something close to a half? 0.9, 0.7, that'd be the 4th power. I'm going to say B equals 0.93 with a big question mark, because I'm just estimating that, ballparking it in my feeble brain. Okay? So, I could write this equation. Find the t such that the amount is half the original amount, right? That'll be the half-life. Again, something we've talked about, something you can easily read about. What is the amount? 0.5 grams. 5.9 times 0.93 to the t equals 0.5. Solve for t. How do you solve for t? You divide both sides by 5.9, take the log, okay, convert it to logarithmic form, something that y'all were very good at when we did it, okay? So make sure you know how to do that. Convert to log form, solve logarithmic equations, exponential equations.